at a conference in Raleigh. We want to have proof there's no curvature. And if we can do that, it's game over. But the rotation is not looking good at this point. We don't want to blow this, you know?
Right.
I mean, we've got $20,000 in this freaking gyro. But yeah, if we dumped what we found right now, we would be, it'd be bad. It would be bad. So what I just told you is confidential.
Okay, I won't say it.
Not any one single experiment proves anything conclusively. That's why we're building a preponderance of evidence.
I think there's a few more experiments we could do with lasers and leveling. I think Jaron's working on a great experiment now that's going to help with all that.
What we're going to be doing is an experiment at Victoria Canal in Holt, California. It's a 3.88 mile stretch. We're going to actually have set up 3 posts, one at the start, one at the end, and one in the middle. And then we're going to shoot a laser from the first post and see where it crosses that first post. So let's say it's 8 feet, and then get it to cross the same point at the far end. And when we can confirm that both are passing the exact same spot, then somebody will tell us what the middle's at. And if the middle's at 8 feet, it's flat. And if it comes back that it's only 5.5 feet, then yeah, I mean that means that the Earth has curvature.
That's a cool experiment, actually, just in general. It's interesting. So I'm trying to think if there's a laser is just going straight. Yeah, they're in trouble here.
So like a laser, like for your cat, I think would be 5 or even less milliwatts. So this is 3,000 milliwatts. The beam will grow as it gets further. And if you put the expander on, it's supposed to get smaller. The most surprising thing I've learned is how hard experiments are. There's so many things that go wrong. I think I didn't give enough credit to people who do experiments.
Usually they have a way to say, well, I don't believe that evidence. But it's rare that you have something which is performed by them and it's just so obvious. There's just no other way to look at it. So I'm curious to see what happens. It's really going to be interesting, actually, like how they handle it. Yeah.
We as flat earthers feel that we have several smoking guns. Several.
There's no curve, but we don't want to present it yet. We want to have the whole package. Between the laser and the fiber optic gyro, this technology is going to kill the ball.
They would like us to believe that the ball Earth has been proven for a long, long time, but this debate has raged on for centuries.
Those make pretty good waves. Jaron.
Nice to meet you, man.
Nice to meet you. Your name? Bob. Could use your help too. We're gonna maybe have you guys do the middle station. We have these panels. We're gonna try the panels instead of, I think, the posts. Okay, we're gonna get the leveler right now. See a red line right around where that green is? This way a little bit. To your right. Press it once to turn on, then double press it. Okay, hold on. Keep it right there.
Let's say this is the light that you see. You just mark where you are putting this.
So it might be that big, you're saying?
I don't think so. I think it'll be under a foot for sure. And then we're gonna have one of these panels in the middle, and then when we have both ones hitting at the same height, then we'll just move the panel in between. The middle people will. And then wherever it crosses the panel, that's it. Then we're done. Okay, where's the...
We're ready.
I got a big beam, so you're going to see it. I just want to make sure you can see it.
Yeah, I can see it, but it's kind of high. It's high.
High?
Yeah.
There?
Or go up a little bit.
Up a little bit.
Up a little, you said.
There.
There?
Yeah, just keep it there. Keep it there.
Yeah, right about there looks good. You got it?
I think the beam's going to be too big, though.
We want you to narrow
The beam.
the beam.
Okay,
It's too big for us. It's going to be way too big for them.
absolutely. Okay. Tell me if the beam gets smaller right now.
That's what we need.
Okay, tell me if it gets smaller. There.
The beam was taking up the whole panel.
I should work on the beam first.
I think you should work on that beam first.
Are the specs on that laser that it should get to that small of a dot at that distance?
With the focuser, yeah, it should be at least less than 4 feet. Okay, I got it on a pretty tight beam, so I'm gonna try and find you right now. Okay, I see the light.
Yes, I definitely see that.
There we go.
Same size?
Thanks, you too. They're all leaving. So.
Yeah, that's okay. I don't mind.
But we should leave.
You too.
It takes 2 hours.
I know, but I'm not gonna just.
You have to figure out that laser.
Yeah, I know. Bob, I'm gonna shoot it, and if you don't see it any smaller, then we're gonna have to reassess this. Is it a smaller beam?
No, it's not a smaller beam. It's the same. 15 feet wide.
Man, I don't know what to do.
Not today.
You'll come back.
We have to, yeah. And you just gotta figure out the way to make it work. We have a backup experiment.
If you're seeing through this hole, through the next hole, and seeing the light at the backboard, or at 17 feet off the water, the Earth is flat. If he's holding it up at 23 feet high and we're seeing the light, well, that's because the Earth's curved. So I should only be able to see it when it's at 17 feet. Okay, go ahead and drive down there, Enrique. You're going to hold the light there. Enrique, how high is your light?
17 feet.
I mean, it's his. We don't see you, Enrique. Lift up your light way above your head. Interesting. Interesting there. That's interesting.